hello, welcome again to another episode of Flying High with Flutter. I've actually slightly changed up my studio a little bit, so you'll see me actually looking at the camera this time because I did some changing around. And what I wanted to say is that we have a great episode today with a very interesting author. We just had some reason we started a little bit late today is because we've got sidetracked talking about languages, actual languages. And but we're going to here to talk about his book and also, some more details about how to actually make great APIs. Because as Flutter developers, of course, we need to sometimes create our own APIs, and so this is really important to talk about. And so now on to the introduction. We have Arnaud Lauret. Hopefully, I have that kind of okay. He
Yeah. Almost.
he is the author of the design of web APIs. Yeah, I think your book is really important. And I was looking, I didn't get the review copy in, but just looking at the table of contents, there's a lot of things covered that I think when you're making an API for your app, you never really think about. And we were talking before the show, permissions is super important. But before we dig into the topic of the book, I would like to learn a little bit more about, who are you? So I just like to transition to, you know, uh, your own self introduction. So you have a chance to fix your name, if in case I got it wrong, and talk a little bit more about, who are you?
Yeah. Thanks, Alan. Thanks for inviting me. So I'm Arnaud Lauret. As you might guess, I'm French. You may also know me under the nickname of API Handyman. That's the name of my blog. I've been working in software for 2 decades, a little bit more. I think I studied my career in 2002. For most of the time, I've been working in the financial industry, connecting pieces of software together using various stuff like RPC, SOAP, Java RMI, and later web APIs. So that was all my career. And years after years, I made mistakes. I complained about terrible um, APIs or web services or other equivalent. And so in 2015, I realized that I have learned a lot by attending my first API conference. So I started to blog under the API Handyman name to share what I have learned along the way so others can avoid making the mistake I did. And by chance, I met a few people, and I've been contacted by Manning at that time to write a book about the OpenAPI specification, which was not what I wanted to do at that time. So I proposed a book about the design of web APIs. And so it was published in 2019. And so it was a success. And afterward, I joined Postman. So it was 3 years ago. And when I joined Postman, my publisher contacted me to say, okay, the design of Web API first edition was a bestseller. What about making a second edition? And I was like, oh, maybe not. I wasn't sure. But when I was thinking about what I have learned after publishing the book and seeing what was happening in the API design space, I was like, okay, the book is still relevant. But it could be interesting to have a refresh and enhancement of the book. So maybe today we'll talk about web API design, but from the consumer perspective, from the people creating application consuming APIs or and possibly creating their own specific APIs. But maybe you can talk about the difference between the two editions. So basically, with the book, the first edition, you learn how to design an API that does the job, that is user friendly, that is secure, that is performant, and how to document it. And the second edition, we can compare the two editions to the Terminator and Terminator 2 Judgment Day movies. The second edition is the same, but bigger and better. I rewrote everything from scratch, but keeping somehow the same structure. And I expanded a lot on how to make your API designer life easier to ensure that you are designing your API always in the same way, always using let's say pagination parameters named correctly, how do you handle errors or that kind of thing, and how to make decisions confidently and consistently across the time. For instance, okay, we want to introduce pagination. We do not want. We must introduce pagination when we are searching things with our APIs. How do we do that? That's not a light decision to take. You need to understand how it works, how people are used to that, and so you need to make that decision once and for all. Be sure that you decide, and then afterward apply it consistently. So that's what the last part of the book is about.
It's interesting about the API, right? So, like, is there something that has really changed? I mean, I think there's always new techniques and new ideas, and also, of course, there's always kind of coming back to permissions. Sorry, but like permissions are really important. There's a framework I've
Yeah.
been using recently that talks about permissions, and what they do, I think, is actually related to a lot of things I saw when I was looking through the table of contents of your book, and it's quite important because you have an API, right? And there's always two things that for every system, whether it's API or not, which is authentication and also authorization, right? And I think authorization, people usually think about, can I do this action, right? That's one thing. And something you also talk about in your book, which is about exposing specific fields. So not only can I do this action, but am I allowed to see all of this data, right? So this is something that is super important and people don't often think about.
Yeah.
Can you
And
talk a
when
little bit
it
more
comes,
about that? Yeah, you're sorry. You just
yeah.
I
I
want to
think
yeah.
especially for when you are creating mobile app or website, you have to be very, very careful about security because you likely have end users and you don't want the data of end users be accessible by anyone. And so API security cover many topics, design, implementation, how to secure API with an API gateway, and there are many things. But just for design, it's essential to understand uh, you talk about permissions, but actually API security starts long before that. The first level of security you can implement in your API is just be careful when you decide to add an operation or a piece of data into your API. Because the best secured API, the best secured operation, the best secured piece of data is the one that is not accessible at all. And so that's really important. When you design your API, you have to clearly choose what operation, piece of data, or an action you will enable for your API. That's the first thing. Then afterwards, if you decide, okay, we need to provide some data which we consider sensitive, you are under no obligation to provide it as is. The most typical example is credit card numbers. You never see full credit card numbers in an application. You only see the last 4 digits. And typically, you can have that kind of pattern for any sensitive data, whatever it is, in your API. Just you pick some data that is sensitive and you transform it by pruning it, by turning it into something which is less sensitive. For instance, a birth date. You can replace a birth date by an age or an age range. And that way your data is more secure because it's less precise. And once you're good, you're okay with, okay, this is our API, all its operation, all the data, all the actions we want to do. You need to decide how to split the API in different parts to ensure that you will be able to grant access to specific operations only to the authorized consumer. Let's say you have, so I come from the financial world, so you have a banking API, and a banking API may deal with operations related to listing accounts, listing transactions, but also transferring money. You can decide to split that into two different realms. The account realm, which grants you access, read-only access to account and transactions, and the transfer rim, which grants you access to all the transfer-related actions. And you can even go a little bit further and say, but in the transfer world, there are redactions like show me the last transfers or show me the registered account to which I can send money. And you can modify those accounts and can transfer money. So you can separate between read and write. So that way, when you create a new consumer of this API, you can say, this consumer will only have access to that specific perimeter, also called scope. And having the scope will grant you access to different operations. That is typically, from an implementation perspective, that is typically handled by a component called an API gateway, which is role is to expose an API and secure it. So that way, when an API call arrives, it has an authorization token attached to it. The gateway check, okay, who is the owner of this token? Who is the application calling the API? What are the scopes available to this API? Does this operation is included in these scopes? If it is a yes, you go through the implementation and the implementation does the job. If it's not the case, the gateway will block you. But afterward, it's not finished. Let's say I have my mobile application, which is granted to make money transfers from account A to account B. And I'm a client of a bank with thousands of account owners. With scopes, security is not enough. I can have a mobile app which has the scope transfer, allowing it to trigger money transfer from account A to account B. If the implementation does a terrible job, it will allow anyone making an API call with the correct scope to take money from any account and send it to any other account. Obviously, that's not what happened. Even if I may have such issue in the past, but hopefully we discovered it before going into production. But it's the role of implementation to ensure that, okay, someone requires to send money from account A to account B. Who is the owner of account A? Is it the end user who triggered the API call? Yes, it's okay. We can do the transfer. If it's not, we can block it. And a typical API security issue related to that kind of topic is, I think there was I don't remember the name of the app. It was an app meant to record audio conversation. Like you are speaking with someone on the phone. If people are still doing that, you can record that. And so there was a mobile app, of course. And the mobile app could retrieve the list of recorded conversation. Each conversation was identified with an ID, which was just a numerical sequence, so like 123. And so some hackers triggered some API call to say, okay, I'm just allowed to see, I think I'm just allowed to see record 1, 2, 3, 3, 4, 5, and so on. What happens if I put a random number? They're able to get a recording from another user because the implementation was doing a bad job. So with API security, you really have to think about the full scope. You have to think about what you put in your API, how you segregate access to different actions. So a consumer can only be allowed to a limited scope of operations, and how the implementation, which is the last line of defense, will check that based on the data available, the user ID or the partner ID or whatever, I can check that, yes, this API call is normal, so I can return the data or I can execute the action. Do you have a question related to security, Alan?
I mean, you covered a lot in there. Maybe let's roll it back a bit, right? So, because I think a lot of the audience, when you want to learn Flutter, it's one of those frameworks that's actually pretty simple to get started. and you can get quite far. But then the question is, okay, now I have this, separate system. Maybe you built your own app using like Flask or even Django, something like this, and then now you need to actually connect the two, right? And if you've never
Yeah.
built an API before, I mean, there's definitely a lot of things to consider, right? Because a lot of people they just start building something, but I think
Yeah.
before you start, I mean, you've stated quite a lot that I don't think I even think about even after an API is built, and so I'd like to kind of talk about what should the first steps be when you start to build it, because it's not just exposing endpoints, sending out JSON data.
Yeah.
You need to really consider, okay, what is it that my user wants to do, and how should I expose that? And even if it's just exposing JSON, I mean, you have choices of GraphQL, you have REST, you have SOAP, but that's more so with XML. You have so many different things that you could do. I mean, you don't have to do REST. You could just have some type of endpoint and just you accept, post, and you could be actually returning something. A GET request should have in REST. I'd like to kind of talk a little bit more about from the beginning, what should I be thinking about and how can I start to design this? What are your recommended steps?
Yeah. And that's typically the topic of the first chapter in my book. And then in the book, I cover in all steps that I described. So I split design. So by design of API first, I make a difference between defining an API and designing an API. Defining an API. So I come from the corporate world, so that makes maybe a little bit different. But uh, the life cycle of an API, whoever you are, wherever you work, can be divided into someone decide to create that we need to create an API for whatever purpose, because we need to gain more customers, because we need to add new features to an existing app, or we don't care. But someone make the decision and kind of give an overall scope or maybe a precise description of what is needed. Then you actually design your API. So I will get back to this in a moment. Once it is designed, you will develop it, you will test it, and you will deploy it. And some people will consume it. So it sounds like waterfall stuff. It's not. It's just a basic representation of all the activities any API will go through. There will be back and forth. You don't have to wait for everything to deploy your API, because actually to make end-to-end test, you need to deploy it. To give it early to your consumer, you need to deploy it while you are still designing it. So it's just the basic steps. So when I'm talking about the design of an API in my book, it's someone decided to create an API. So now we need to design an API that will meet the defined needs or the requirements. And so in this design stage of the life cycle, there are many things to do. The first thing will be to identify the capabilities that the API must offer to meet the requirements. And when I say capabilities, I'm not talking about get/this, post/that, or do whatever mutation in GraphQL. It's plain English or French or Dutch or whatever. At that stage, you need to speak the language understood by all the stakeholders. It's just pure subject matter or business language. Okay, we have that type of users. They need to do that. How do they do that? They go through step 1, step 2, step 3. And so you decompose what the users need to do, how they do it. And that way you will identify many different steps in many different use cases. And when you're looking at all those steps, you will identify the unique capabilities or operations that your API needs to fulfill. It could be read a user, send money, check people profile, whatever, you name it. Once you have that, you will actually design the programming interface. But before choosing the programming interface, you need to decide what kind of programming interface you will use. So you mentioned REST, GraphQL, and SOAP. So I hope that nobody's do SOAP anymore, because that's super complicated. So typically it will be REST in 80% of case, and GraphQL I'm taking worldwide. And such a question of who are the consumers, what kind of action you have in your API. For instance, if you need to create a real-time chat system, a REST API is not the best option. Maybe you will use something like WebSockets because that's the best architectural option. So what's really important is to not choose a type of API just because you are a REST fanboy or a GraphQL fangirl. You need to choose because that's the tool you need to fix your problem or meet the requirements. So that's really important. Once you're done with that, you can actually design the programming interface. So in my book, I focus on REST APIs because I consider it the most mature API style. It's the most used. Still nowadays, it was the case 6 or 7 years ago when I wrote the first edition, and it's still the case today. And many of the learnings and the teachings in my book can be applied to other APIs. And the REST APIs are rooted into the REST architectural style, which gives some guidance not about designing APIs, but how you design distributed systems. And that's really important to understand. So when you have that background and you know how to design a REST API, why they work that way and so on, you can look at other APIs and see what is missing, what they bring as an enhancement, and you can balance them. But learning REST API, even if you are focusing on GraphQL, learning how REST API works is really a good insight for you. So let's get back to the design. So you have someone who define what needs to be done, you identify the capabilities, and then you design the programming interface. So for REST API, you need to identify the business concepts your capabilities will manipulate. We call them resources. Then for each resources, you see the operations that are attached to them. So let's say you have an account, you can read it, you can modify it, and so on. And you will afterward identify the HTTP method to represent those operations. But for today, that's not really what matters. Then you will design all your data. You need to design the responses. And to design responses, you need to identify all possible options, the success, the errors. You need to be careful with errors, especially when you are creating an application with end users interactions, because if your API just respond with, oops, there is an error in your request, and that is caused by the input of the end users, just telling them there is a problem with the data you just provided to us. Please fix it without any other instructions. Your end users will not be able to fix it, and probably you will. They will go elsewhere, and so you will lose customers. So you need to design all that. In order to foster discussion, if that's needed, around all of that, you can describe your API with a machine-readable format, an API specification. So in the book, I'm talking about OpenAPI, the OpenAPI specification. So that's pretty useful because using that kind of format, you can have a discussion around this with your colleagues. And you can also generate quickly a mock just to test it in maybe a prototype of application just to see how it works. Do we have what we need? So it's not an intelligent, but just a dumb one. Can someone help working on that? And once you're done with that, you can implement it. And obviously, as for the life cycle, it's not a question of step 1, steps 2, step 3, and waiting to have fulfill every steps. You can have back and forth, iterate, so that way you don't have to wait for months that something happened. So that's a high level and first layer of API design. But you need to look at different perspective on top of that. So when you just do what I described, you have roughly an API that does the job. But you need more than that. You need to be careful that your API is user-friendly and interoperable. So user-friendly relies to, okay, naming things correctly so people can understand them without the need to be an expert in your internal system, to be sure that you're not exposing internal things that people shouldn't see, and that can also returning nice errors. For interoperability, it's hard for me to say that because I'm French. You need to care about the type of data you will use in your app. For instance, let's say you are returning uh, a time or a currency. Yeah, yes, you are returning an amount of money. So an amount of money is a numeric value like 100 and a currency, dollars or euros or whatever. For the currency, you could say, okay, we can invent our own codification and say a US dollar will be 1 and euro will be 2. But that's not interoperable because it's your own invention. You can leverage existing standards, international standards. So there is an ISO standards for currency. I never remember the name. It's ISO 4217. So if you have currency codes, you have the same for countries and so on. So that's broad interoperability. But you need to be careful about internal operability. Internal in the sense inside your API and across your APIs. Let's say that I have an API that deals with accounts, and I have an API separate that deals with transferring money from one account to another. In both worlds, I need to identify an account. It would be nice to use the same identifier in both worlds. That way, my APIs, plural, are interoperable. I can take one data from a part of my API and use it easily in another. That's the part of for interoperability. So once you have work on that, you have an API that does the job and is user-friendly, interoperable. So that means developer will not take months to use your APIs, and they will just need a few lines of code to use it. And especially if you are working in the mobile world, you need to consider other things, and especially efficiency. Because, for instance, let's say that still my banking stuff. I have accounts with years and decades of transactions. If anytime I has to retrieve the list of transactions of an account, I get all this data, which may represent megabytes of information. Obviously, nowadays, with a 5G connection, it may be not a problem, but it may be. And also, I don't know how it works in all the countries in the world. In France, we have, when you have a mobile phone and a phone line, you have limited access to data. So limited in the sense you're allowed to use hundreds of gigabytes or megabytes per month, per week. It depends. So the less you use, the better. And also, the less data you use, the less battery you will consume on the smartphone of the users. So you need to be careful about the data volume you will get. So typically for transaction, you need to be sure to provide just pagination, enabling searching transaction by date, maybe by name, by type, or whatever. So the consumer can get exactly what they need. You need also to be careful about the flow of operation that are needed to achieve something. Because let's say that when my banking mobile app starts, it needs to perform. So I need to first list the account of the users. then I need to list transactions, then I need to do that, then I need to do this, and so on and so on. You can have a cascade of operations that will take a very long time. And so the end user is waiting for seeing something. And so that's why it's very important, but I guess that people who are used to creating mobile apps are used to that. It's very important to be careful about how long will it take to get the data that matter. If it takes more than, I think it's 500 milliseconds, it's an issue, because beyond 500 milliseconds, the human brain starts to be bored. It senses that, okay, it's long now. I don't want to wait more. So by designing your API correctly, you will be able to work around that kind of thing. And if that means designing a highly specific API, which is a little bit far from the original, let's say, business intent, you may consider designing a backend for frontend, which is deeply optimized for performance, and keep your business API as a middle layer so they can be used by many different consumers. And in that layer of constraint, I talk about security, efficiency. I didn't talk about security, but we already talked about that. So the security is another topic in the layer constraint of API design. The last layer is just the surrounding context. And usually it's about how the business or the IT systems work and how they will impact the implementation of my API and how they will impact the consumers. For instance, I remember a time I was working for a French bank. It was impossible to perform money transfers every day between, I think it was 11 p.m. and 2 a.m. because there was some batch processing running and we couldn't do any transfer. That's something you need to be aware of when designing your API, because at one point, you will need to block money transfers. If by chance you are able to fix that and hide it from the end users, no problem. But if you're not, you need to integrate that constraint in your API. And so maybe at one point, the transfer operation can return a 503 saying, oh, we are temporarily unavailable. And in the response, you can indicate when it will be available again. You can also have an endpoint specific, providing the downtime of the system, which are not 24/7. And it can be also a question of just business hours. Sometimes some actions are verified by humans, unless they are replaced by artificial intelligence. So there are many things that you need to consider to be sure that they are integrated or in the design or hidden by the implementation. And with that, so we have an API that does the job. We have an API that is user-friendly and interoperable. We have an API that takes care of constraints, such as security, performance, overall limitation of business and IT systems. Once you have covered all that, that's pretty good API. But you know what? You need to design probably other APIs. You will need to modify the API you have just created. And even when designing one API, we'll design many operations. And when you're doing all that, you will take many decisions. And you will make many decisions which are always the same, or they should be. And so you need to be careful about, okay, how do I make the same decision consistently without losing sanity? And when I say decisions, there are thousands of them. Choosing a type, how you represent date, is a decision. Do we use timestamps, Unix timestamps? So it's date in seconds or milliseconds. Do we use ISO 8601 standards? Do we use both? When? For what? How do we name date? Do we use date suffix in them or not? Which case are we using for query parameters? How do we structure resource path? Do we force the implementation of pagination on every such operation or not? What is the response when the user try to access to something, but they are not allowed to. Do we return a 401, 403? What kind of information do we return in the response? How do we model error? There are many questions that you need to answer once. And afterward, you need to keep to the previous decision. And that can be very complicated, even when you work alone. But imagine when you are working with a team of different people or many different teams across an organization, and you need that your API share a similar look and feel. Because if you do not do that, it would be a nightmare to use them. Because what people expect is when I'm switching from one operation to another, from one API to another, what I have learned before, the code I have returned before, I expect it to work the same with the new API and operation I'm discovering, as long as it is created from the same organization. And it would be nice that all our organizations across the world share common patterns. So that way, poor developer of consuming application can do their job easily. And so to do that, first you need to make decision confidently. So it's not just a question, oh, we will do that because I like it. No, there must be a reason why we do things a specific way. So, and you need to make to have a rationale behind each decision. And then you need to aggregate all those decisions into guidelines. So that way, someone who needs to design a search operation just need to look at the guidelines, at the search, how to design a search operation recipe, and have all the instruction. So when designing a search operation, you need to have this, and that, this way, and so on and so on, and how you handle error, and be sure that people don't need to guess what needs to be done. For instance, if you decide that errors are handled a specific way, people designing a specific operation need to know how errors are handled without the need to remember, oh yes, we have defined how to handle error in another place in our wiki or in a GitHub repository than somewhere else. Somewhere else, yes. You need to have all information gathered in one place. But people don't read them. People don't read guidelines. They need to design the API quickly. So what you can do is automate your guideline as much as possible. So there are programs called, if you are programmer, programs called linters that can check your code is free of bugs, suspicious construct, and have the correct information presented in the correct way. So that way, the code written by developer A, B, C, D, or Bob, Alice, and Terry is written in the same way. You can have the same for APIs. So that's where having formats such as the Open API specification can be useful, because you have a machine readable description of your API, and you can run a program to check it matches your guidelines. You can, so in the book, I'm illustrating that with a linter called Spectral. It's an open source linter. So you can create your rule to say, okay, let's target this specific element. Okay, let's target all property names or request bodies or whatever. And you can do some check like, are we using the right case, or, oh, this looks like a search operation. Are there pagination parameters? Are there, let's say, 200 responses with the right data format? And so you can check everything. And once you have that, it frees your minds of many details. You even don't need to look at the guidelines for the first time. You just need to, okay, let's design an API, and the linter will tell you, oops, you need to do this, you need to add that, you need to replace that. And you can just design the API without the need to constantly refer to the guidelines. And also, if you are working in big organization, you can implement that at your in your CI/CD chain, and to be sure that no API that goes against the guidelines can be published, for instance, can block them. Or you need to have some validation, because sometimes in the real world, you need to publish a terrible API because you need it. just to do some tests. And okay, but do that. Um, yeah, and so that way you can simplify your design. And also using the OpenAPI specification, you can have blocks that you define once and for all. For instance, if all operations have a 500 or a 401 response, you can define it once and use it across all of your APIs. So that way you don't need to think about that. One thing I forgot to mention in all this cycle, so when you design your API, you design an API that does the job, user-friendly, interoperable, constraints, and then you need to think about how to simplify your life. When you modify an API, that's another constraint. You cannot do what you want. Typically, you cannot remove data, you cannot remove operations unless you know what you're doing. So it's essential to identify the modification that we call breaking change that could cause the consumer to crash or do unexpected things. For instance, if I get back to my money transfer API, if I remove the transfer operation, any consumer query will get an error from the gateway telling, oops, the operation does not exist. But let's say that the transfer operation still exists and was initially intended to transfer money, let's say in dollars. And I modify it to transfer money still in dollars, but using cents. So I'm moving digits there. So when a consumer which has not been modified sends, let's say it's reverse. So it was cents and now it's dollars. So they were sending to send $10. They were sending 1,000 cents. And now you say, no, it's not cents, it's dollars. So I was thinking sending $10, but I send 1,000. So I made a modification which is not the usual breaking change in a sense that it did not break the consumer, but it just break my company. So that's really important when you modify your API to think about that. So it's all of this is explained in the book. And yeah, and so to get back to the making decisions and so on, that's really the huge novelty of the second edition. It was not present in the first edition. So if you have read it and you need to work on API at scale and how to make your API designer life less miserable, that's a really interesting topic, and that's why you should buy the new edition, even if you have read the first. More or less, if you have read the first edition, I recommend reading the second because everything has been written, simplified, and I go deeper in many topics. To give an idea, I think the book is probably 80% longer. The second edition is 80% longer than the first edition. So there are a lot of new editions. So that's a lot of stuff. Alain, I don't know if you are aware of all of that when designing web APIs.
I mean, maybe not all. You said a lot of things, and also still more things are popping into my mind as I was thinking about this, because you're talking about more on the creating a public API, and I think there's definitely so much to think about over there too. Um,
Yeah,
but I mean, we didn't really talk so much about versioning, but you did kind of touch on that, saying like, okay, if you're going to cause breakage on the client, then that's a big problem. You have to version on that one. How to version is another kind of question. I've seen
yeah,
sometimes you can send a parameter, sometimes it's you change the URL. There's a lot you could do. The other thing
yeah,
too
yeah,
that
yeah.
because
Two
I'm
things about
yeah, sorry, go
yeah.
ahead.
There's two things about what you said. So regarding the book and what I described, it may looks like it's for public API, but actually I make zero difference between public and private APIs. So the book, everything I say, everything I wrote about API design applies to both. It's just a question of the consequences of not succeeding with your API, which are different if you are using a private or a public API. So that's really important. You need to design. You must design your API, even if it's a private one that only you use. That's the first. Regarding modification and versioning, uh, I focused on breaking change because that's what really matters. Versioning is fundamentally just a representation and a process of how do we handle change in our API. But the first thing is, how do we make sure our design will help us make change smoothly in our APIs? So there are patterns that you can use in your design to ensure that you will not break things later. For instance, you are returning a list of elements. You do not return just a list. You return an object that contains a property that is a list. So that way you can have more metadata added later, typically pagination. And when it comes to, we need to modify our existing API. And this API, we need to evaluate the cost of the breaking change. So first we need to identify, do we need to break things? Is it really necessary? And how do we handle that breaking change regarding existing consumers? Sometimes it's just okay to say, okay, let's break things because the consumer, it's me, and I just need to update my app, and I'm okay with that. So if you are creating a mobile app, one thing I learned the hard way in the past is always have a mechanism that allows you to force users to update. So when the app starts, it can check, okay, am I up to date? Yes, no. And you can enforce the update. So that way you can break things without any issues because consumers are forced to update their app. So that way you can introduce breaking change. But sometimes you cannot do that, especially when you are publishing a public API or you have a private API that is used by many different teams inside a big organization. So that's where you may need versioning. In a sense, we may need to differentiate the old and new version of the API. So that way, old consumer can use the old version and consumer updated use the new version. The problem with that is how many versions do you support? And how long do you let consumers before saying to them, okay, now it's too late, you need to upgrade your code or you will break. So you need to define a versioning policy. And it could work well for public API, but for private API, that's a nightmare. Because there may be business constraint, budget constraint, and so usually it's better not to version in a sense, not to break your API for private API and live with errors from the past. That's based on my experience. As for public APIs or any other kind of APIs, a way to deal with modification is to, and I think it's Stripe that does that. They can support an API call in any version since Stripe has been created. So that's fantastic. They can do that because at the implementation level, when an old version of an API call arrives, they transform it to a more recent version, they process it, return a response that is transformed to the old response and returned to the consumer. That imply the unique implementation is capable of fulfilling the request. So they carefully modify their API based on that. So that's another option. So the thing around API versioning is not focusing on where do we put the version in the path, in a header, or whatever. It's about how do we handle change and what is the cost of that specific change. Because sometimes it's okay to break things and sometimes it's not. Do you have experience with that, Helen, regarding modifying APIs for mobile apps?
It's a great question. Yes, I had a very well, it's still kind of ongoing, but had a very long-term app. I switched to GraphQL because I found that I like to be able to control how much data is coming back because sometimes I reuse some endpoints. Um, Now the thing is, of course, over time, like you said, you need to modify it. Usually, I ended up adding some extra fields and sometimes actually removing fields because originally we were using some data and then we actually simplified the page so that we're actually pulling less data and maybe I changed the how we store it. So the way I did it for my app, practical experience was that, of course, I use GraphQL. And what we had is as soon as you turn on the app, the first thing it would do is see, okay, are you using the latest version of the app? If
Mm.
not, we force them to update the app. So we actually would have to call out to like the App Store for iOS, and I think the same thing
Yeah.
for Android, and we'd actually force them to download the app. And I think I would wait between 2 to 3 versions of my app before I actually removed fields on the API request. So of course I would remove it in the GraphQL request,
Mhm.
and then I'd wait 2 or 3 versions, and I would actually remove those fields from the API itself because they weren't used. And again, this is not a public API, so I didn't really concern myself about changes I was doing. But yeah, I think that worked out quite well. The only thing I had a problem with is something that came up in my mind as you were explaining some things is about duplicate requests, right? Because we had some users. Based in Hong Kong. We have some users who live on islands out there, and of course the reception's not that good. So sometimes the request would be a little bit slow. They would tap multiple times.
Mm.
I wanted to get your feedback on nonces, right? NONCE. So adding like something to the API to make sure that you don't get duplicate requests. Do you have any feedback about that kind of idea?
Yeah, that's really important. So I have no experience using Nonces for performance thing, but more I had concern in the past about having end users repeating the same operation, especially when it comes to transferring money. Because I remember a time I was working on a website, so it was before the mobile era, and people were clicking on the transfer button, which was not super responsive. So they fire a first money transfer, and the button and the web app was not responsive, and so they were like, "Did I click? Not sure. I will click again." And so they were sending money again, firing the same money transfer. So to fix that, we had I implemented some check in the backend to ensure that the same money transfer was not triggered twice or multiple times within a given period. Um, but I think there are probably many other techniques to use around that. So maybe at least Nonce can allow you to make a difference between requests. And so if you fire the same request with a nonce, the same nonce, you can say, oh, that's the same request as before, so I will not process it again. So that can help. As for performance, there is also an infrastructure question, and having data centers located near to the users as much as possible, but sometimes it's not. But yeah, so it's what's interesting there regarding API design. It's important to not forget that API design, careful API design, will help you avoid many issues. But not all the issues you can have with APIs. You will have to work with implementation. So you really have to care about the surface of your app, so the web API, and what happens below with the implementation, and also what happens on the consumer side. So, for instance, for this wire transfer stuff, at the UI level, we ensured that the button could be clicked only once. That's a small thing, but that avoided us many problems. So you really have to think at each layer, what can I do to ensure that the experience is smooth and there is no issue?
Yeah, I just kind of want to go over the nonce thing. I'm guessing not everybody at home may understand what is a nonce,
Yeah, yeah.
NONCE. You'll have to correct me if I get this wrong. But my understanding about nonce is there's basically 2 use cases for it. I'm not even sure if I'm saying that right. I feel like I'm saying it in a French way, nonce. um, so it's what I see it as is a way to stop duplicate requests from happening, right? So
Yeah.
if you have a network partition, aka some kind of interruption between when you send a request and the response comes back, you don't want the same operation to happen twice. Like Arnaud said, if you want to do a transfer of some money to somebody, you don't want to transfer twice the amount, of course. And so a nonce will help to say, okay, did this request happen? Yes, therefore it must be a mistake. So let's just, there's 2 ways. There are a couple ways you can handle it, right? One is that you could error. The other one, of course, is kind of piggybacks onto the second, way a nonce could work, which you talked about, which is like you can cache the response, right? So you could just resend the previous response in case it got lost, or it's just like, you know, it's just another way to cache, right? So if you say, okay, give me this user's data, and it could be an expensive operation, you send it out to them, you have it in cache, you use the nonce as a cache hit. They ask you for the same thing again. Oh, by the way, here it is again. No need to go back to the database. I have it in memory already. So this is something I
Yeah.
think is quite important.
The main idea with nonce is typically we let the consumer give a unique identifier, unique from their perspective, to request. So that way, they're sure that it will be executed once. And if, let's say, there is a network issue or whatever happens, the request is resent again with the same nonce, it will not be replayed. And I like the way you see that in a sense that we will not return an error, but we return the actual response that should have been returned in the first place, because that way that smooth the end user experience. And that's really important when you are creating APIs, because even if there are things that are used by programs, actually APIs are used by programs that are mainly used or are often used by people. So everything you do with your API can impact the end user. And so the way you would handle a nonce, a duplicated request, is really smooth, because that way the end user don't see anything, and they are not afraid of, oops, I send money, I'm not sure if it's actually sent, so should I do the same money transfer again? And so that creates stress for the end users, and we don't want that.
Something I think is really quite important to talk about is that user-defined nonce, right? I think that needs to be some kind of contract you need to really talk to users about, because at some point you have, I mean, let's just say that you do cache it. You can't hold all requests for the whole application for forever for different reasons, right? One is that you may need to do a server restart for a new upgrade. You may just not have enough memory. I mean, it's really something to talk about. So having that kind of saying, okay, we can cache this for say 2 hours, etc. I'm not sure what is. There's no magic number, but it's something that I think is good.
It really depends on the topic of your API, and
Yeah.
depending on the data you can, and beyond nonce, because caching data is important for anything.
Also.
Let's say I'm retrieving a list of transactions. If there are no transactions, I can return the cached response. That's it. And so that's really important to think not with predefined rules that you apply anytime you need to cache or nonce or whatever, but it's really contextual. You need to think, what is the kind of data I'm dealing with? What is its volatility? And even if it's volatile, can I show, how do you say that, stale data, outdated data to the end user? What is the consequence? Is it okay or not? You have to think about all that. And based on that, and especially in the world of mobile apps, you can decide, yes, it's okay to store data for a certain amount of time on the device and show it to the user without doing any call to the API, or it's not. It really depends on the topic. And that is something the developer of the consuming app must not decide on their own. It is caching, a local caching policy is defined by the owner of the data, so the API provider. If it's you, that's okay. If it's not you, you have to comply to that policy.
That's why it's also very clear to have that contract between you and whoever's using your API to make sure you understand about that. Yeah, you also talked about caching, right? Busting caches. That's that part is always tricky.
Yeah,
Well, I mean, we have gone on for a while, right?
yeah,
So, of course, this topic is, even though it sounds simple, right? APIs. I mean, come on, it's easy to. It's not. That's why you can go on and on forever about this. But because we are starting to kind of get towards the end of the time, I would like to kind of like start to wrap up, and we can of course talk about where to get the book. But I think let's just do it this way. Since you are the expert in APIs, Do you have any kind of parting thoughts we can leave the listeners is about, when it comes to APIs? What do you like recommend, or yeah, anything that comes to your mind?
The first thing is any web API you create, you need to design it. You don't need to spend hours of month, days of month, just a few minutes. Think about the critical elements I described today, and obviously I described roughly them in my book. But you need to design it, even if it's just a private API, a backend for front end for my mobile app. I'm the only one using. You need to think about it, because if you don't do that, you will deeply regret it later. That's really the first thing. And if you want to do that, read my book. And I will stop there because I could talk for days or months about that. It took me 2 years and a half to write the book. So yeah, there's a lot to say, but designer of your APIs and be careful about security, efficiency, and so on, because it will impact your end users.
Okay. No, I mean, great talk. I can't wait to actually dig into this book because I do something that have to build APIs and authorization about who can do what, who can see what is definitely something that comes to my mind. And the noncing thing has come up a couple of times because yes, I'm probably gonna have to do something with mobile APIs, so that's something I need to consider about. But in any case, yeah. So for the book, it's called Design of Web APIs. Yeah, the second edition. I think still now, when you order the second edition, usually you get the first edition from Manning.
I think you can have the first edition in ebook form, and if you
Yeah.
order the second edition in printed book, you will get the printed book, the second edition ebook, and I think you get access to the first edition ebook. But maybe it's temporarily uh, as the book is in Manning early access program. So the
Hmm.
book you can actually so the book is finished. You can read it on the Manning website or get the
Yeah.
ebook if you buy the book, and you will get the printing book probably in the beginning of July. So we are in the last phase. We are the Manning team is copy editing and so on, but the book is finished. So what you read on Manning website is very close, 99.99% close to the final book that will be printed.
Okay. July is still some time off because yeah, I did see it's basically complete. Sorry, we're in April,
Yeah,
May,
yeah.
June, July.
So
Wow, that's
it's
still a few months.
printing a book take a long time because the
Yeah.
I think I will have finished everything, checking copy editing, typesetting, and indexing probably at the end of April.
Okay. That's why
Yeah.
it takes so
So I
long.
think that the usual timing is when a book goes into production, it take on average 113 days to get the printed book. That's an average. So you can still buy the book and already read it. You just have to wait a few weeks to get the printed book. And if by chance I meet you at an API conference, I'd be happy to sign it. And if you are lucky, I will have a stamp because I have a stamp with my own face for a special dedication. And I'd be happy to discuss with anyone on LinkedIn. Don't hesitate to contact me to talk about API design and the book.
Okay.
Either if you don't like it, I'm happy with good feedback.
Okay, that's good. Yeah, so in the show notes, we should have a link to the book along with the discount code. So if you're interested in picking up the book, I think it definitely is one of the books I want to go through. Um, yeah, so otherwise, it was great to have you on. Um, Maybe if they do a third edition, we'll have you back on again to talk about, the difference between the first, second, and third.
Yeah, I need time to recover, and for now, I'm in a never again mood. Maybe it will change in a few years, but yeah. So to be honest, I've been working 7 days a week, 12 hours a day because I have a job, and writing the book because I'm a slow writer. So that was really exhausting. Hopefully, I'm really happy with the result. And I'm French, so when I say that my work, I feel that my work is awesome. You can trust me that that's really awesome because French tend to be not over expanding about what they're doing or what others are doing. So when I say that it's really an awesome book, I really think that it is, and it's not just to say buy my book. So yeah, third edition, maybe we'll see in 20 years. We'll see what happens.
Well, I mean, when you wrote the first one and they asked you to update it for the second one, I don't think you said you weren't expecting that, right? I mean, there's a few years in
No,
between.
I was expecting it would be smooth and yeah, but it was actually very hard because I'm French, so writing English is the first barrier. Thankfully, this time I had the help of Grammarly, which really helped me to fix my Franglish, and especially long sentences with many words. But it's really a question of arranging the ideas, finding the best. Each sentence of the book has been carefully carved, so it conveys something that is meaningful, important, and that you can understand it. So that's the kind of work I had to do. Just to give you an idea, the latest PDF, which doesn't contain everything, is 550 pages. The initial book was 350 pages. The actual content was probably 300 pages. So that's massive modification. There are 250 figures, probably 150 listings, 70 exercises, which were not in the first version. So that's a huge amount of work. And I really squeeze my brain and the brain of many other practitioners to put everything I know about API design. So I don't think there are other books that can be compared to this one. There are other books talking about API design that cover more different aspects, but there are no books like mine. So if you want to really design API and avoid learning it the hard way, read my book. 20 years of experience in there.
I'm looking forward to reading it. Again, thanks for coming on.
And thanks
Yeah,
for
like I said,
inviting me.
we'll have the discount code in the bottom, and yeah, if people do want to get in touch with you, you said can find you on LinkedIn, and do you
Yeah.
also have a Twitter or anything else?
So I have a Twitter account, but I don't use it anymore. So LinkedIn is my now favorite social network because I tend to don't have much time and I want to focus on one thing at a time. So LinkedIn, you can look at my blog, API Handyman. I will probably start writing again in a few weeks. But yeah, LinkedIn is my favorite contact point. And any API conference, you will probably see me at API Days in Paris this year, Nordic API in October. But yeah, if you are an API conference, you may see me. Do not hesitate to come talk to me. I'll be very happy. And ping me on LinkedIn if you have questions or comments.
Thank you for coming on, and yeah, looking forward to actually reading the book.
Yeah, thank you.